Yes. So today we are discussing the lens maker formula. Okay. What we are discussing? Lens maker formula. Now, what is lens maker formula? Lens maker formula from the names that do not means don't think like that. It is a scientist name. Okay. Lens maker is not the name of the scientist, but it is that formula that is used to manufacture a lens. Okay, lens basically that whatever the formula we are using to manufacture the lens, so that formula that we are using for making the lens, that is known as lens maker formula. So what is we are going to discuss today? Lens maker formula. But for this lens maker formula, what you need to know first, the refraction through the spherical surfaces is very important. We know that whenever, suppose this is the spherical surface, okay, so whenever the light is travel from medium 1 to medium 2, means from rarer to denser or from denser to rarer, so we got a relationship for that, that is mu2 upon v minus mu1 upon u, and that is mu2 minus mu1 upon r, where v is the image distance, u is the object distance, and r is the radius of this spherical surface. Okay, so this is the refraction, the formula for the refraction through the spherical surface. So today, with the help of this formula, we are going to deduce a relationship, that is which relationship or which formula that we are going to use for making the lenses. That formula is known as lens maker formula. Okay, so what heading you have to write? Lens maker formula. I will do it for convex. You have to do it for concave. Very easy. So just write the heading, that is lens maker formula for convex lens. Assumption I told you at what assumption you need to take? Assumption that you need to take first. The object we are taking over here, that object is point object. Okay, and the angle, that is the incident ray or the refracted ray, that makes with the what? With the principal axis are very small. This is the second assumption. And the aperture we are taking, it is also very small. That these are some assumption we can take to deduce the lens maker formula. Okay, so now let's find out this relationship for convex lens. So lens maker formula, I am doing it for convex lens. So the diagram is very important. So first, what you need to do, you need to draw the convex lens, that it is an optical center, and the ray of light that is passing from the optical center, and it is known as principal axis. Okay. Okay. So suppose I have placed the object over here. Okay. Point object I have taken here. So what will happen? What will happen? The ray will go. The ray will travel. Okay. Now the ray will travel, and what will happen? Because it will moving, the refractive index of this medium is mu1. Again, the refractive index of here is mu1. But whenever we are talking about the refractive index of the glass, this, that is mu2. So first, the ray of light is going from mu1 to mu2. Okay. Then in the second case, it will go from mu2 to mu1. So first of all, the light is going from mu1 to mu2, from rarer to denser. So if we draw a normal, so what will happen? Whenever the ray of light is travel from rarer to denser medium, the ray of light after reflection, suppose it have to go like this only if there is no refraction. But there is a refraction, so what will happen? The light ray will bend towards the normal. So this is the normal. This is the normal we have drawn. This one is the normal. Okay. And the ray is like going like this. So when it wants to bend, it will bend like this. It will bend like this. Okay. Whenever the ray of light is passing from rarer to denser, it will move from towards the normal. Draw the diagram. Okay. Okay. Now in this situation, this ray have to meet at this point somewhere like this here. This obviously if you talk about the refraction through the surfaces, this have to meet at this point. But is it possible that it will meet over here? No. Why? Why? Because now again, now the refractive index of this is mu2. Now in the second surface, this is the first surface. I told you this is the first surface, and this is the second surface. So now for second surface, what will happen? Now the light will travel from mu2 to mu1, from denser to rarer. So again you will draw a normal over here. So whenever the light ray will passing from denser to rarer, so this is the normal. This is the normal, so it will move away from the normal. So after the refraction through the second surface, this ray of light will meet at this point. So I can imagine this is I dash and this is I, and this is B. So here at B I have placed the point object. Due to first surface, there is a refraction, but because of the presence of second surface, again we got the refraction. At the end of the day, the image will form at the point I. So if we consider this distance, so this is U, the first image distance, that is suppose V1, okay, or V dash you can consider, and this distance is V. Okay, now this is the first surface. So for first surface, the radius of curvature is R1. For second surface, the radius of curvature is R2. So to draw the length maker formula, you must need to know the diagram. So draw the diagram and then we will find out the relation. You can draw the diagram like this. This we are doing the length maker formula. The ray of light will go like this. Because of this first surface, it will move away from that towards the away from the normal. And in the second case, because the right is this, so it will move like this. Here it is moving towards the normal, you can see. Here it is moving away from the normal, you can see. So this is the diagram we are getting. Okay. So this is the diagram of length maker formula, and that is very important diagram. So now if we'll apply the formula to first surface. So you can write over here also. When the ray of light is coming from mu1 to mu2. When the ray of light is coming from mu1 to mu2, the image will form because of first surface as I dash. Because of first surface is formed at I dash. So what formula we can do? Refractive index of second in which the ray is going upon image distance minus refractive index from where the ray is going upon object distance is equals to mu2 minus mu1 upon R1. Why? Because here the refraction is due to through first surface. Now in the second case, what is happening? The ray of light is going from mu2 to mu1. First the light enter from rarer to denser, means from air to glass. Second case, the ray of light is going from glass to air, again from denser to rarer. So when the ray of light is going from mu to mu1, this is the case. This is the case. So whenever the ray of light is going from mu2 to mu1, what the formula will become? Now one of the very important thing. Now for second surface, this image distance will behave as the object distance, because for this surface, this distance will be act as object. Okay, virtual object. It may be a virtual object, not the real object, but it will behave as a virtual object. So for second case, in this case, this V1 will play as the role of object distance. So we can replace this U with V1. This you need to know that for the second surface, the image distance for due to the first surface will behave as a virtual object for this second surface. So we can replace this u with the help of v1. I'm not applying any sign convention over here, so do not apply. Okay. So now the Volta formula will become, now from mu2 to mu1 the right is going. So I told you whenever the medium will change, so in mu1 it is going again upon quality v is the image distance. Now from mu2 it is going. Now for mu this portion, this will behave as object distance. So instead of this, we can write this, and it will become mu1 minus mu2, because this is because of the second surface, so I will write. So this is the first equation, this is the second equation. This is when the ray of light is going from this mu1. This first equation is for when the light is going from mu1 to mu2. The second, when the light is going from mu2 to mu1. But for this, the image distance due to the first will behave as a virtual object for the second surface. Note it down. Only 43 students are present. Now what else we can do? Now we have two equations. I'm just removing this one. When the light is going from this and that, and also I'm removing this. So we can compare both the equation 1 and 2. We can add them, we can subtract them. So let's see what we can do. So we are adding them. So after adding them, mu2 upon v1, mu2 upon, this is the positive mu2 upon v1, and this is negative mu2 upon v1. So they both will get cancelled. So it has become mu1 upon v minus mu1 upon u. And here, if we take mu2 upon mu2 minus mu1 as common, so here it will become 1 upon r1 minus 1 upon r2. You can apply the mathematics over here. What I have done, I have just added the equation 1 and 2. मैंने क्या किया बच्चों? What I have done, I have added the equation 1 and 2. So ये वाला part is get cancelled. So this we have taken. If I take mu2 minus mu1 as common, so this will become negative. So it is become 1 upon r1 minus 1 upon r2. Okay. So if I take mu1 common over here, so it is 1 upon v minus 1 upon u. It is mu2 minus mu1. Or in bracket, I can write 1 upon r1 minus 1 upon r2. So 1 upon v minus 1 upon u. What is this formula will become? This will become 1 upon v minus 1 upon u is equals to 1 upon f. Length formula, thin length formula. So what I can write? Mu1 upon f. Mu2 minus mu1. 1 upon r1 minus 1 upon r2. So this formula is generally known as lens maker formula. What formula it is known as? Lens maker formula. Do it. Note it down. Now what else we can write this? What else we can write this? I'm just erasing this. I hope you have noted down this. Note कर लिया होगा सभी ने. ठीक है. तो अब मैं थोड़ा सा ये वाला पार्ट्स को erase कर रहा हूँ. थोड़ा सा इसको और आगे हम लिख सकते हैं. If you want to write it in the different forms, okay. So how we can write? Let's see. Okay. So this is the final formula, or I can write it 1 upon f is equals to mu2 minus mu1 upon mu1. I have placed this mu1 in the denominator. 1 upon r1 minus 1 upon r2. Clear? Or when suppose if the rarer medium is air, then the refractive index of air is 1. And the denser medium is any medium. Denser, that may be any medium. So we can take it mu. If we are talking that if you take that rarer medium air, so the refractive index of air is 1, and the second medium that we are taking, that is we are taking any medium.